Alright, good day. Welcome to today's tutorial on indexing turnings on our CNC. One thing that we want to discuss first to get the understanding of what an indexer is. It's a device similar to a lathe, and it is called not a lathe. It is called an indexer. The reason for this is we are able to index the turning by a set degree. Whereas a lathe is just a continuous spin, rotation that you'd use your chisel to carve out the profile. With a indexer, we are able to control the rotation by direction and create, add items to our turnings that we would not be able to do on a lathe. So as we did here, I added this two-dimensional profile sweep weave onto our turning. So this is what we're going to do in this tutorial, go through the steps to be able to create this profile. The first thing we have to understand is how Vectric produces turnings. Even though it looks like it's a turning, the way Vectric sees this is as a flat object, very similar to what you would do just in a three-dimensional non-turning object. It just wraps this around. To understand what is happening with that, we're going to go over and start a new Aspire. And I will mention that what we're doing today here is only able to be created in Aspire as we are creating 3D components, and we need Aspire to be able to do that. So we're going to go in and start a new file and set up the job dimensions. Starting at the top, the type is a rotary, 50 inches long, 4.5 diameter, and the lower left. We'll talk more about this when we set up the job for real. But right now I'm just starting in here to be able to go into and import a model that I have created that is just a square or a square post. So I'm going to select that to import it. We can see that it is fitting within our material. The red, the blue is our model. So as it imports, it does look as the object that we wanted. Now we can go to the 2D view and see the grayscale is looking a little odd. As we see, we are, 14 some inches high, and that 4.25 inch cube is stretched out across the top. Well, the reason for this is it is unrolled. So if we go to our 3D tab, we can click this button right here to unwrap the 3D viewing. So this is basically how Aspire sees all three-dimensional objects, if it be a turning or a flat object. But for the turning, what it's doing is taking this flat object and wrapping it around. And that's how we're going to do it, only the opposite. We're going to create a flat object, a three-dimensionally object, and then we're going to have Aspire wrap it around for us. So to get started with that, we'll just come over here, File, New. I need to save those changes. We'll take a look at the settings here to be able to create an object like this one here. Alright, now we're going to set up the job to create this turning using this profile. So we're going to come over to Aspire and set up a new job. The job is going to be a rotary. The length is 50 inches. The diameter for turning is 4.5. Now Aspire does not see this being a square piece. It is always seeing it as round, so I have to keep that in mind. Diameter 4.5. The Z0 position, we're going to set up the Z0 to the center of the rotational axis. So this is options here are the same as we have two-dimensional top of material or table surface. In this case, we don't really have a table surface, but we have a center of axis. So that is what this setting is. The X and Y datum position is the lower left. Now, when we're working with turning, the lower left and top left are really the exact same position, because X and Y zeros need to be, or the Y zero in this case is really zeroed above the center of the axes, above the center of the turning. So the wrapping that happens is here. Part of it comes halfway this way, the other half comes around and wraps along the bottom. The orientation of the indexer, this depends on how you have your indexer aligned on your machine. Is it parallel to the X, parallel with the Y? We could flip the direction, which is like the rotation, and I will select OK. So now what we have done is we have our job, which is the X across the width of the screen is the 50 inches. But the Y is a lot higher than that 4.5 that we entered in there. The Y is actually the circumference of a 4.5 inch diameter circle. So the first step that we're going to do is just take a look at some of this clip art that we have in here. If we scroll down, we have rotary profiles. You could simply grab one of these profiles and bring it over, stretch it out, scale it however you would like. I chose not to do this. I drew my own profile, which I wasn't crazy about any of the ones that I saw here. So I created my own profile, and we're going to duplicate that. So I'm going to right-click, copy, come over to our other instance of Aspire, right-click, and select Paste. Come back over to our Drawing tab, and just to help keep us organized and clear on where things are, I'm going to click to align jobs to the center of our material. Looks like it is basically already there. Now, I didn't have to do that, but I'd like to have it for visual purposes. The way we're going to create our three-dimensional object here is using a two-rail sweep. So we need two rails and a cross-section. So what we have on our drawing right now is the cross-section we're going to use. We need to create the two rails. Should also mention with the two-rail sweep, we don't have to have the cross-section scale to be exactly what the object is. It will automatically stretch out and scale according to the distance of the two rails. But in this case, I did draw it out to scale of what we want our cross-section to be. Again, helps to visualize exactly what we're getting, and we know exactly how it's going to end up. So I'm going to come into Create Vectors under the Line tool and draw a line from the endpoint up. This is going to be the one side of the rail curve. Now, I wanted to go up the distance of the Y value. Now, the Y value is a little obscure because it is the circumference of that 4.5 inch diameter that we entered in. So if I'm not sure what that is, I could just simply in that Y value hit Y, then equals. That enters it in there and click Add. I'll hit the space bar to keep the line tool open, but disconnects that line. Come over to the opposite end, click the line, and again come over here and click Add, then Close. So we now have our two rails that we're going to use for our two-rail sweep. Selecting those two rails and bringing them down onto the material and centering it up. We'll close the alignment tool, and now we will do a two-rail sweep. To do that, go into the Modeling tab. I have the two rails already pre-selected. You don't have to. Let's start with them unselected. So use the two rails. Let's select one, hold the Shift key down, select the other rail. Select to use that as the selection. Now we will select our cross-section and apply. See this on our 3D view. Now if you do this and you notice that it appears to be flipped, that the top side is on the right side and the bottom side is on the right side, that is in the order of the rails that you selected. So we selected the left side first, then came over and did the right side. So we'll select apply to keep those changes and close. Going to the 3D tab, we can see that we now have our radius block here, and to see what this looks like unrolled, we could just simply click that unwrapping, and we basically have what you've probably done already is basically a flat three-dimensional object. We will roll that back up. Our next steps are to create the square top and the square on the bottom, similar to what we have right here. Alright, so our next step is to create a square profile across the top of our new model. And to do so, we're going to have to do the similar thing that we saw when we imported that square post. We need to be able to unwrap a square and get that scallop type of cross section. We could do that by drawing a square. Draw out a square. I'm going to make this square to be 3 by 3, selecting apply and close. Now, with this square selected, we're going to come over here to transform vectors and unwrap the selected object. Now this is a new feature, I believe, in version 10. Prior to version 10, this was a gadget that was able to be used. So just simply clicking this button here and apply will now unroll that square and gives us the scalloped cross section. The next thing that we need to do is create our rail sweeps, the distance for the top and the bottom. And to do that, I'm just going to draw out a line from that distance right there, selecting that line, and I'm going to move that up to the top of the job. We'll do a Control-C, then a Control-V, which pastes that, and moving that down to the bottom. And it snaps to the bottom of the job. So now we have two rails, a top rail, a bottom rail, and our cross section. So selecting the two rails, going to the Modeling tab, two rail sweep, and use those two selected rails as the selection. Selecting that cross section, selecting apply. It now sweeps that cross section across those rails. Close there, go to our 3D view, and almost, kinda, maybe, no, not at all what we want, but we could correct that. That is somewhat of a square, even though we see radius here. We just have to correct the size and the merging of this. So notice in our components list here, we are building up names here. Default names aren't always the best because right now I don't know which component is what. I can only assume that component 1 is the first component, component 2 is the second component we selected. So going to the 2D view, just going to verify that when I select component 1, the main component gets selected, component 2, the square. So great. So now I can know what the two are. I'm going to right click and give them a specific name. Alright, now to correct our issue that we have here. That is done through the combine mode of that component. So selecting the component, coming up and clicking properties, and we have our combine modes right here. I believe we have to use the merge low here. That is now creates the square. That's looking good. Close the combine mode. There's a couple things that I'm seeing here is some of the turning is extending up past our square. That is okay. We're going to change the size of our component around a little bit. So selecting the component to be able to get our control points. I'm going to drag that component out to where it is almost in line with the bottom side of this curve right here. Come onto the right side and do the same basic thing, bringing it right there. Now taking a look at our 3D view. Yep, that's going to knock that down. You can see that's merged in to where that radius is now filling in and coming up alongside of that square rather than extending out past it. So our next step is to be able to create the lower section square. Creating the lower section is done the exact same way that we did the top section. So come back into the 2D view, zoom out, and we will end up using this same cross section for the bottom side. So again, I'm going to select this cross section and create a line. And there's probably 100 different ways of creating this rail. This is my method, not necessarily maybe not the best, but it is working for me at the moment. I'm going to do a Control C, Control V. I'll move that to the bottom. Select both of those rails and just make sure, and I'm going to use the align tool just to make sure that I got those aligned just right to be there, make sure they're parallel and the start and ends are perpendicular to one another. So with that done, the two rails are selected, going to the modeling tab, the two rail sweep, going to use the selected rails as the selection to use that. Coming over here to create or select the cross section, then apply. It creates our lower cross section, and we're going to probably have the same issue there. So knowing that, I'm just going to select there and resize that component out to right there. Take a look at our 3D view and see that we have some work to do there. Before we get to that, again, I should have renamed this at the start of that component, so I'm just going to name that bottom. And we're going to take a look at the properties for this one here. Selecting the component that we want to modify the properties for, coming in and clicking properties, and coming through to click the options that we want here. And there is what we want. I could make this a little bit bigger, this square profile, but I like the idea that it does give us a little bit of a radius corner on those corners, so that I didn't want it to be perfectly square. So that's the reason why I set the square up the way I did. So that is the bottom rectangle, and now our basic profile is complete. Our next step that we're going to take a look at is, before we add this weaving and pattern to it, we're just going to quickly look at some of the tool pathing to toolpath the basic profile of the post here. Alright, before we get started with the profiling, we need to add or extend some of this object here, because right now, as the 3D object, if we go to toolpath this, there isn't going to be anything that's left holding this. We'll have the headstock down here chuck to our material, and the live center to the center here. So if we come around and cut through on this, it's just going to pop off. There's nothing there that's going to hold it in place anymore. So we're going to do that and take a look at what the zero plane is. I'm going to come back over and just take a look at our component list in our completed model already, and that is this zero plane right here that we're going to modify the height of that. So coming here, here is the zero plane. I'm going to select this, go to the options, and I'm going to increase the height of the plane to say 1. And it kind of did it, but look, it like blew everything up. Well, the reason for that is, again, it is our combine options. And it is also, I believe, has something to do with the placement of where that is. I'm going to move that up into the list, and there we go. So now that we have our zero plane with some thickness that is not going to allow our cutter to come all the way down to the center of our turning, we could change the size of that plane anytime we want. If we think that we could make this tab a little smaller in diameter, we could do that as long as we think it's going to hold in place. That is okay. But we're going to come over here to the 2D tab, and we're going to create some vectors for our toolpaths, just as we would if it were a three-dimensional flat object. We toolpath it just the same way and have the exact same options. So we're going to use a vector to contain the model. So I'm going to snap it from the bottom side of the material, dragging over and snapping and aligning it to the top side. And I am overlapping a little bit on both sides, or extending past the model a little bit on both sides. And I could get detailed about what exact distance that is, but I really don't care. I just want to have it, make sure that we're extending out past a little bit. So with that done, we could just simply come over to the Toolpaths tab. First, we will select a roughing. I'm going to use to the selected vector. I'm going to select the cutter that we're going to use is a 1/2 inch ball nose. I'm going to use the same cutter for the roughing as I am with the finishing. The only difference between the two is the roughing. I'm going to increase the step over to 30%, and our pass depth is 1/4 inch. So I'll say OK to that. Making sure we have the selected vector. I am going to do a raster rather than a Z level. The raster for the indexer turning in such to get the whole width. I tend to like the 3D raster. It seems to be a little bit more efficient than the Z level, but the Z level roughing, working with the indexer, is a little more exciting and fun to watch. We'll just leave that as the 3D roughing and click calculate. Take a look at what that looks like previewed. Looking pretty solid there, looking all right. So the next step is to create the 3D toolpath, selecting to do the 3D finishing, also having that same exact vector selected. We want to do the selected vectors using that same 1/2 inch ball nose, only this time I have a step over of 10%, which is going to be much smoother. Set to raster. We will calculate. If that's selected, we will preview that toolpath. And there it is. It's looking all right. So our next step that we want to do is create some two-dimensional profile texture or a pattern along this section here, and that is kind of a slight weave. So that is going to be what we're going to focus on next. Alright, to create this weave pattern, I've used the clip art that we have in our drawing side. So I'm going to switch back to our drawing side, going to the 2D view, coming down here to clip art, do the weaves. Now, when selecting a pattern for this, the top side along the positive Y and along the negative Y or 0Y needs to be the same pattern. It needs to line up with one another. So in selecting a pattern or even just drawing out your own pattern, know that the top side, and so I'd like to show all of the new layers and going back to the drawing side. So what I mean by this is, remember, this line plane on top here is the exact same line that we have down along the bottom. So with a couple things that we want to do, we're not doing anything with this as a 3D or using these profiles at all, so I'm just going to delete those and going to resize this vector. Going to scale it up to the size or the size of the job in the Y direction. So using the scale selected vectors, also have the X and Y unlinked. I'm going to change the Y value to the size of the job. Then center, wrong button. Then center that on the job and close. So now what I mean by this side needs to match up to this side here. So this curve at this point where this is ending, the bottom side, that is going to match up right here. So we could extend that out past a little bit to make it the same, but we will have a little bit of a line where this curve and this curve match one another. You might be okay with that, you might not, but just remember in your design that this top side and this bottom side is the same point. So I'm going to click, kind of a double click on that selected object and just going to drag that over to this point right here to where none of this is hitting into that curve. Going to do the same thing on the top side. And now we're ready to create a toolpath for this one. Close the preview, and for this we're just going to simply create a profile toolpath. Going to cut to a depth of a 1/16 of an inch using a V-bit, and we're going to go on the line. And I'm going to just click calculate. Now there is going to be an issue that we run into by doing this. Just preview all these toolpaths. We saw the weave there, but it didn't show up on our view. So some might wonder, like, what's going on? It's definitely there. Well, what it is we've already removed some of the material here, and we're only cutting in a 1/16 of an inch. So what we have to do, double click on that profile, we have to come down and click to the option to project this onto the 3D model. So with that selected is taking this 3D or this two-dimensional toolpath and projecting it onto the surface of our model. So selecting calculate for that one, and now preview all the toolpaths once more. And there we have it. Just rotate this around to where we could see what I was mentioning with the two sides coming together there. That might be okay, that might not. You may even want to split this in half to where we have this same type of line on the opposite side. And we could do that simply by going into this vector here, and let's give it a try. So what we're going to do is, with that selected, going to come over and change we did not need the help button. Click the toolpath tab. We're going to scale this back down to half the size of the Y. And again, we could bring out a calculator and do the math, but I could just do that divided by 2 and then hit the equal sign. It's going to do that math for us. Now with that selected, I'm going to move these selected vectors to an absolute position of y0. With that object selected, going to do a Control-C to copy that onto the clipboard. With that selected now, I'm going to go back to the move, also absolute, and Y to the position of the Y, moves that to the top. Now we'll paste that object back in that I did to the clipboard. Now going to the Toolpath tab, double-clicking to modify that two-dimensional toolpath. This time we have 2 objects to select, selecting the other one. We'll calculate that. We have to reset because it was already drawn there and preview all the toolpaths. Now we should have 2 sections that have that matching side. So that makes it more symmetrical. So just understand that turnings, you have to pay attention to the top side, the bottom side, and that they are the same. So this is the basics of creating a turning, being able to create a toolpath, 3-dimensional on this. I hope this was helpful, and you all have a good day.